All right, it's gonna be a super short lesson. Let's go ahead and get started because once the boys get here, then we get no progress done. Y'all know that. So just put your own name. You don't have to put Ms. Ramirez. I'm still considering allowing you to use this booklet on the test tomorrow. Don't know yet. So your rules for that is you're only allowed to write in this booklet what I write. If I go around and I see anything extra written, you don't get to use it. So no, you do not get to add additional notes to this. But anyway, all right, so we already established that these lines don't perfectly line up. So we're just gonna go and we're gonna go over these rules. The very first rule is your product rule. What is one way that we could recognize or distinguish the difference between the product rule and the power rule, which is on the third row? How do you distinguish the difference between the product and the power rule? How do you know the difference between those? No, first row, third row. You see parentheses, but you could technically see these in parentheses this way: a to the power of m times a to the power of n. So parentheses really would not be the distinguishing factor here. More than one base, correct. Notice here on the very first row, we have how many separate bases? 2 of the same base and 2 exponents. And for those of you barely walking in, I am recording, so keep that in mind. We have 2 of the same bases, 2 same bases, and 2 exponents. So when you have 2 separate but equal bases and 2 exponents, what do you do to the exponent? Look at the rule. There's a plus sign. You add. Those of you that just walked in also covered, I might not allow you to use this booklet tomorrow on your test. The rules are you can only write what I write, nothing else. If you add anything else, you forfeit being allowed to use your book. Why would I not look at it? Of course I'm gonna check it.
Like tomorrow.
All right, so we said the parentheses cannot be the only distinguishing factor, or it can't be, because you can see this rule with parentheses, but you can also see this rule with parentheses. So we said this one has 2 of the same base. How many bases do we have here in the power rule? There's only 1 base, but you have 1 base and how many exponents attached to it? 2. So there you can see the difference. We only have 1 base with 2 exponents attached to it. And when you have 1 base and 2 exponents, what do you do to the exponent? You multiply it. In this one, yes, you do multiply. So make sure you're being careful and paying attention to the difference of the 2 rules. Okay, quotient rule. Quotient rule, how do we recognize it? What are we doing with the powers? We're dividing 2 powers. We're dividing 2 powers. 2 powers. Remember, the base with the exponent, that creates a power. Base in the exponent creates a power. So when you divide 2 powers, what do you do to the exponent?
You divide,
Subtract. Remember, we said we're going to treat that fraction bar as like a minus sign. M minus N. Always top minus bottom. Now, when we subtract, that is the same as bringing your power to the top or the bottom of the fraction.
To the top.
It brings your power back to the top of the fraction. And I'm telling you, just in case it turns into a negative, meaning you're going to have to switch it again, or you're going to have to switch it. Now, this is the rule. The second to last rule is the one we learned yesterday. converting from exponential to radical form. Now you didn't see it with these variables, so let's do it with some variables that you're familiar with. Draw your radical symbol. The base that we had in the notes is what?
Hey.
X.
Oh, yeah, X.
The number in the upper right-hand corner is your what?
Your exponent.
Your exponent. If you don't know what the exponent is, or if it doesn't have a number in this spot, you put a,
1.
what's the name of the number out here? The index. If you don't have a number in this spot, what do you put? A 2. Okay. You could put a 2 in parentheses here, and you could put a 1 in parentheses. That way, you know, if there's no number in this spot, you put a 2. If there's no number in this spot, you put a 1. There, 1. Now, when I convert this to exponential form, my exponent becomes a what? It becomes a fraction. Now that fraction is going to be composed of what over what?
Inside over outside.
Inside over outside. Inside over outside, meaning I over E or E over I. E over I, exponent over index, inside over outside, exponent over index. And this is the way the formula looks on this, on the formula chart for the STAR test. So you do need to know how that looks for future reference or how to use that. Now, negatives. When you have a negative exponent, or you cannot have a negative exponent, if it's a whole number, if it's not already in a fraction, you turn it into a fraction. You turn anything into a fraction by putting it over 1, but we're not going to go ahead and fill in the 1 because I don't want you to get confused and think that you flip this to the bottom and anything that's at the bottom flips to the top. Only the power with the negative exponent, oh Lord, only a power with the negative exponent is what needs to be crossed over. What phrase did we use? Cross the line. Good. Cross the line, change the sign. Huh? That has no,
You're not
no.
gonna get it.
I know I didn't get it.
I'll explain it in a bit.
Okay, explain it later. All right, so we cross this power. This power crosses my fraction bar. It crosses the line. So we change the sign on it. It goes from a negative to a positive. Now, when you have something at the bottom, but nothing at the top, that's when you fill it in with a 1. If there are other parts to your answer, not necessary to fill in with a 1. And we'll continue to see examples of that. Ooh. Can I undo this? Why did it? Ah, yes. I don't know why. Anytime I erase something somewhere else, some other part moves. Anyway, so what if I'm going to draw, I'm going to split it. What if I have 1 over a to the power of negative n? What if my negative exponent is at the bottom of the fraction? What do I need to do? You move it up. Find any power, just the power that has a negative exponent. If that's 2 powers, you move 2 powers. If it's 1 power, you only move the 1 power. Don't move everything. Just the power that has a negative exponent moves to the top, making that positive. Once again, if there's other parts to your fraction, you fill it in with that. If there isn't, you could put a 1, not necessary to put a 1 under something that's already at the top. Flip the page when you're ready. This is just an overview of all the rules. The actual test review, I'm going to give you a page after this.
We're gonna do it by ourselves?
Yes. All right, so biggest takeaway or biggest thing to remember, most important thing to remember is that your exponent rules, your laws of exponent, laws is another word for a rule, Angel, is that it applies to the exponents only. The addition, the subtraction, the multiplication, that applies to the exponents only. You're not going to be subtracting, multiplying, or dividing the coefficients. All right. So PMA, that is an acronym that can be used to help you remember what to do with the exponent. If you see a power in parentheses, what do you do with the exponent? You multiply. You take the exponent outside, multiply it with the one inside. So it becomes x to the power of 3 times 2. 3 times 2 gives us positive 6. But if you're multiplying two powers, two separate powers, two bases, two exponents, what do you do to the exponent? Add them. 2 plus 5. And that gives you what? 7? Once again, now you can see it a couple of different ways. You can see it as x and the x to the power of 5 in parentheses. One of them outside of the parentheses, one of them inside. They both represent the same thing. You're still multiplying two bases and two exponents on them. You could even see them both in parentheses, x squared in parentheses and x to the power of 5 in parentheses. All three of these represent the same. In all three of these examples, you're going to add the exponent. Hold up. All right. 5, make that prettier. Okay. Doesn't matter if it's in parentheses or not. These still represent multiplication. All right. Division, when you are dividing powers that have the same base, you are going to treat that division bar like a giant what? Subtraction sign. So we said we use it as a minus sign. When you subtract, it brings the whole power, it combines the power and brings it to what side of the fraction? It brings everything to the top. And you always want to subtract top minus bottom. 9 minus 3. Since we wrote top minus bottom in the other page, no need to write it here. And what is 9 minus 3? 6. No longer in fraction form. Okay. What if this was flipped around? What if we had x cubed on top and then x to the power of 9 on the bottom? You always subtract first. That is a note I will allow you to write. Subtract first. Subtract first, then switch. Then switch the power if it's necessary. Switch. Subtract it first, then switch the power. It's always easier to subtract first. You can start off by switching. I'm not saying you cannot get the right answer that way, but most of the time, if you switch it and then subtract, you'll end up having to switch again. So we subtract, it brings everything to the top. And this time we are subtracting not 9 minus 3, but 3 minus 9. And 3 minus 9 gives us what?
-6.
X to the power of -6. Can I leave a negative in my final answer?
No, yeah, no.
Nope. So you bring just the power with the negative to the other side. If it's at the top, you bring it to the bottom. If it's at the bottom, bring it to the top. Once you switch it or once it crosses that line, it goes from a negative to a positive. Now, in this example, since there's nothing left at the top, I can fill it in with 1. Okay. All right, flip the page when you're ready. Almost done. Negative exponents. We just covered this. We covered this a little bit. When you have a negative exponent, remember, cross the line and change the sign. Now, in this case, can we subtract first? Why not?
Well, no, you can't. The negative.
They're not the same base. They're not the same base. So in this example, we actually do have to what? What have we been doing? Splitting it. Let's split it. It's easier to split it, even though you only have 2 powers. More than likely, you're going to have an example where it has 2 x's on the, or 1 x on the top and bottom, a y on the top and bottom. So make sure to split it first. X to the power of -2 is at the top of the fraction. Because it is a negative exponent, or because that power has a negative exponent, I'm forced to move it to the bottom. And once I move it to the bottom, it becomes x squared. Now, since there are other parts of my answer, I'm not going to fill it in with the 1 just yet. Other side. Another group that we have is y to the power of -3. That is currently at the bottom. Once again, it has a negative exponent. So the only way to make it positive is to move it to the top. Once it crosses that line, y to the power of +3 or y cubed ends up at the top of my fraction. So I'm going to go over here at the end and put it all back together again. You want to go from the left to the right. In the first group is my x's. The x ended up on the top or the bottom? Bottom, x squared. Next group is my y's. Y ended up on the top or bottom? Top, y cubed. Split it apart, then put it back together. Easiest way to tackle a problem like this. Split it and then put it back together.
You don't subtract from there because they don't have the same basis, right?
Correct. Don't subtract, they don't have the same basis. How many different groups are we going to have here in this next one?
Three.
4. Here we go. First group is going to be of my what? Numbers. We have 1 on top. 5 and 4. Do I subtract the 5 and 4? No, because the subtraction rule applies to what only? It only applies to the exponent. The 5 is not the same size as that 2. It's not an exponent. What do you do with a regular fraction? You simplify if possible. Simplify. You simplify if possible. Now, if I type 5/4 into the calculator, nothing's going to happen. So I'm going to move on to the next group. The next group is for my what? X's. We have x to the power of 1 on what side of the fraction? The top. Do I need to move anything, subtract anything? No, I'll leave that one alone. So next group is my
Why?
y, and y to the power of -2 is on what side of the fraction? Can I leave it there?
No.
Because it's negative. So I'm forced to move it to what side? The bottom. And it becomes y squared +2 at the bottom. Last group is for my what? The z's. Now z to the power of -3 is on what side of the fraction? So this time, instead of moving it to the bottom, I'm going to end up moving it to the top. It's easier when you see each one separately, in my opinion. I think I've had more success with you guys separating and then putting it back together than I have any other year, okay? So now from left to right, the first group, what do we have?
5, 4.
5 on top, 4 on bottom. They're already in the correct spot, or they're already in the indicated top and bottom spot. No need to do any switching. X goes where?
Top.
X to the power of 1 stayed on top. Y. Y squared, we put it at the bottom. Z. Top, we ended up moving it to the top. And there's your final answer. Tackle these problems one at a time, and it will make life easier, okay? Ready? Last example. Can you guess what example this is? Anything to the power of 0. So I'm going to write or draw a giant 0 over my words. Anything to the power of 0 is going to give us what? Is going to give you the number 1. Anything, doesn't matter what it is, anything to the power of 0 is going to give you, it's going to equal the number 1. Okay, so we're going to write 4 examples here. What if it's x to the power of 0? What do you get?
1.
What about a big number? 1,000 to the power of 0. Still a 1. I know, it does look like 1,000 degrees. All right. What about 4y to the power of 0?
4, 1. That's 4.
So remember that that exponent of 0 only applies to what? It only applies to the y. So only the y, the 4 is still there. The 4 doesn't stop existing. Only the y will turn into a 1. Now, does that make a 41?
No, this goes 4/1, but you don't have to put the 1.
Not 4 over 1 either.
Oh, 1 times 4.
This is the same as writing 4 times y to the power of 0. So 4 times 1 gives us 4. That's why I tell you, whenever you have other parts in your answer, you can cancel that out, because 4 times 1 is 4. It would have been the same as canceling it out in the beginning, but that's only because there were other parts. An example where there are no other parts, let's say, for example, we have x cubed y to the power of 5 over z to the power of -3. Everything raised to the power of 0. What answer does that give you?
1.
Why? I have 3 different parts. How do you know it's 1? Everything's connected to the 0. This 0 is going to be multiplied by everything inside of the parentheses, and there's nothing else outside of the parentheses. So I do need to know that it is, or it gives me the number 1. Got it? All right. Now before I give you the assignment or the test review. All right, before I give you the test review, I'm actually going to work one of these out with you, but I'm going to do that before giving you the paper, because then I have people that do not pay attention. Yes. Your name. So number 15 on your test review. We worked with something similar to this yesterday, but I need you to look at the difference in the question for this problem and the question for 17, 18, and 19. In 17, 18, and 19, it says write the expression in exponent form. So we're going to do in 17, we are going to do what we did yesterday. We're going to take it out of the radical and change it to exponent form, where your exponent becomes a fraction. 18, you're going to change it to radical form. Take it out of the parentheses, put it back under the root, under the radical sign. But if you look at 15, it's just asking you to simplify this problem. It doesn't say anything about converting it to radical or exponential form. So we have to actually simplify this. How many different parts are we going to have to this one? 3. There's 3 different groups. We have 4 to the power of 1, h to the power of 8, and k to the power of 6. So the first group is 4 to the power of 1, and 4 to the power of 1 is in the parentheses. What do we have outside of it? 1/2. Now it's okay that I have 1/2. Not like I cannot type that into the calculator. When you have 1 base and 2 exponents attached to it, what do you do to the exponents? You multiply them. So I get 4 to the power of 1 times 1/2. And what is 1 times 1/2? 1/2. Now 4 raised to the power of 1/2 will give me what? You can type that in. 4 raised to the power of 1/2. Practice this. Don't just stare at it. Staring at it isn't going to help you. And it gives you 2. 4 to the power of 1/2 will give you 2. Next group is for my h's. We have h to the power of 8 in parentheses with the 1/2 outside. 1 base and 2 exponents attached to it. What do you do to the exponent? You multiply, becoming h to the power of 8 times 1/2. What is 8 times 1/2? 4. Last group we have is k. K to the power of -6 inside of the parentheses. I will leave this up so you guys can copy it, so don't worry. I just need you guys participating. And we end up multiplying the exponent. So -6 times 1/2 will give me what? Now, k to the power of -3. That is currently sitting where?
On top.
On top, meaning I have to convert it to a now fraction, even though it wasn't a fraction before, and move k to the power of -3 where?
Down.
To the bottom. And it becomes k cubed at the bottom. So once I put everything together, I'm going to go over here to the side.
2h4.
What goes at the top? 2h4. And what at the bottom? K cubed. Okay. So make sure you pay, once again, attention to the question. If it says converted to converted to exponent form, then you can put it in exponent form. But this one does not say anything about converting to exponent or radical form. Got it? All right, let me give you the test review.